Abhi, this afternoon session actually is to be taken by Dr. Sanjay Sharma. Uh, that will be taken up on the topic of assessment of the damage done due to the various type of disasters, but mainly it would be on earthquake. So till the time he joins, I will continue my presentation because we left it unfinished. And you all understand that being host, you know, I can take up any time whenever any faculty is getting late. So you have to just consider that. So there will be minor changes in the schedule. For the centers, we have already sent the timetable by email. And one request which I have just got about 10 minutes ago, I am sending the timetable to them as well. If any of the center doesn't have the timetable, please let me know. So we'll arrange to send you the timetable copy. But remember, there will be few changes in that taking place for the reason because that is done on the basis of availability of the experts. But more or less, the sessions or the coverage will be same, which is given in the timetable. So, which center has not got the copy of timetable so far? I believe the Jodhpur centers have already got it. Only कैथल सेंटर जो था उनका शायद नहीं था, कनेक्ट नहीं है. जींद, ओके. Okay, so let's continue with our earlier presentation. So disasters which we discussed about different 31 types of the disasters, I believe that most of you might not have expected such a big list to be categorized as disasters. Probably our vision stops somewhere near 8 or 9 of them. Now whether these are natural or human made, they are common throughout the world. So that is something a kind of solace for everyone, that it is not that a particular country is affected. Different countries are affected, maybe of the different types of them, and they continue to occur without warning and are increasing in their magnitude, complexity, frequency and economic impact. When we say they are increasing in magnitude, so this means that if the flood were coming to a particular extent, now even the extent has gone higher. Likewise, the earthquakes, the intensity is going up, and then complexity, instead of that they being simple in nature, they are now getting complex, and the frequency of occurrence is increasing. I will show you some data which will tell you that how frequency of occurrence is increasing, and also in terms of the economic impact, means that where you could earlier recover in a short while from the adverse effects of disaster, probably now it is going to take a little more time, and then it is causing the socio-economic changes in the society and the nation more vivid than it used to be earlier. If we say that the type of disaster can affect one country, suppose I say that a disaster of the magnitude 7 comes, so if it goes to Japan and it goes to USA and in India or Bangladesh, so you'll find that the impact of the same disaster is going to be different in different countries. So they will pose a more severe problem either with the situation where the population density is higher, or secondly in the case of underdeveloped countries. We need to understand that the first aspect of higher population density is very well understood, because if you're densely populated area, if the disaster stuck over that, so obviously more number of people would be affected. So it can have effect on number of people affected, but if you evaluate in terms of the economic terms, then in terms of economic value, it may not be that large as could be the large in terms of the number of people affected. So this means that if you measure in terms of economic losses and in terms of the human losses of number of people affected by a particular type of disaster, you may not find always a straight correlation between the two parameters. So it could be that in one country the number of people affected may be more, but economic loss may be less. And in another country the number of people affected may be less, but economic loss may be more. We'll see how it really goes about that. That's very, typical aspect to be understood. During the second half of 20th century, more than 200 worst world disasters occurred in different parts of the world. Second half of 20th century. So we are just trying to recall that how from the past the changes have been taking places. And it claimed lives of around 1.4 million people, and losses due to natural disasters are something like 20 times greater in the developing countries than in industrialized one. Now this is a big gap. If I say that in developing country or underdeveloped country the losses can be as high as 20 times than industrialized one. So it is a two-way adverse effect. In one terms, because they are already the people who are having less income, so obviously anything goes wrong is very severely affected on them. And then their capability to overcome the disaster is also limited. So thereby the losses would be more predominant. Even if the same type of disaster occur, they will be more predominant in underdeveloped countries than the developed or industrialized countries. Unfortunately, the continent where our country is placed rates the highest in terms of natural disasters. So Asia is the worst affected continent in terms of the casualties and tops the list due to natural disasters. This is some disasters which are listed in this table, and they are termed as worst disaster of the world. As early as China 1931, something like 10 lakh to 25 lakh people to 2.5 million people, and that was on account of the floods. So neither you nor I was born by that time, so it's only historical. But this remains still today the world's most terrible disaster, 1931, so more than 85 years ago. Floods again in 1954 in China, and 40,000 people were killed. What we are showing here is actually the list of casualties, not the list of affected people, list of people who died. Cyclone in 1970, 3 lakh people. Bangladesh cyclone again in 1991, 1,39,000. And this is fresh still in our mind, 2004 tsunami. I think that was a time when all of us came across the word tsunami, what tsunami is. So many countries were affected which were in the sea side, particularly Indonesia, Sri Lanka, India, Malaysia, Somalia, Bangladesh and Thailand. And total casualties were to the tune of 2.3 lakhs. Then Hurricane Katrina 2005, USA 1836. Now you could see that this is again termed as world worst disasters. The casualties are little. Do you see the difference? Only 1836 compared to 3 lakh or 2 lakh. This figure is very small, 1836. But yet it is termed as world's one of the worst disasters, for the reason because they are much well prepared, but in terms of the economy the losses were much higher. Then Siachen earthquake in 2008, which was more extended to the China, resulted in deaths of like 87,000 people. Then cyclone in 1970, Bangladesh again, 3 lakh people got killed. Cyclone named Nargis in Myanmar, 2008, just after the Hurricane Katrina. 1,38,000, and Haiti earthquake in 2010 killed more than 3 lakh of the people. So we'll continue this piece of information as I mentioned you earlier, and the designated speaker Dr. Sanjay Sharma is with me already. Up. So I will continue. As I said, I'm the host, so I can take any time whenever it's free. So at the liberty. And now Dr. Sanjay Sharma is with me. Dr. Sanjay Sharma is a professor in civil engineering. He has been head of department for quite a sufficient period of time, and now is head of the campus development activities, which involves lot of civil construction works. He has been working for about last 2 decades on the area of non-destructive testing and gradually working on the rehabilitation of the buildings. So this basically, as I was mentioning you, this basically involves at how the old buildings, which have deteriorated maybe 20 years, 30 or 40 years, those who have deteriorated, how to find out their residual strength, so that from the safety aspect, you can make a decision that the building is sustainable and is safe to be inhabited. Now, similar thing happens when the earthquakes or any other type of disaster will shake the building and will substantially result in reduction of the strength. So you could see large cracks or some smaller displacement, and visually they are very very horrifying, and always put a question mark that whether it is safe to be there or in. So the techniques which are available to us now with the technological advancement, lot many techniques are available. How to make good use of them and how to evaluate the structure, and what are the parameters to be taken into consideration, what are the IAS guidelines, that he's going to share with you. And let me mention, he has done completely lot number of projects for various government organizations, and in even for Chandigarh administration or other our such government bodies, whenever they feel the need of assessment of the structural safety of the buildings, they generally approach our organization for the same. I happened to accompany him on one or two occasions. One I remember was the post floods of 2000 in Himachal Pradesh, where the bridges were damaged a lot, and then we were to find out the residual value of the piers. The piers fortunately were intact, piers and abutments. And on another occasion, we went to Jalandhar for evaluation of some building in a temple building was there. So I extend welcome to Dr. Sanjay Sharma and deliver his session. So
Okay, Professor Dugal, thank you very much for introducing me, and I welcome all the participants. That I see that there are about 6 centers, 4 centers. Okay, and okay, so and let me say that I'm sorry for getting a little late. I was stuck up with somewhere else. As Professor Dugal has explained that in case of can see in buildings or other structures, uh, you can see that whenever we see any earthquake or maybe some other sort of a disaster, we find that there are a lot of damage to the buildings. And uh, it is important that okay, when we are maintaining our building or we are carrying out their routine assessment, so we should have basically that we assess the sort of thing that okay, how much basically the what is the present condition of the building. That is important because in case of any say disaster occurring at that time, if the building is in a poor condition or it is in a bad condition, you will be then the damage will be more. And as you must have seen that many times, even we was explaining various disaster. I think if we look back and see that what happened in Bhuj earthquake during 2000, 2002. At that time also there were many multi-story buildings which basically were able to stand that sort of earthquake. But there are buildings which are constructed newly also, they got badly damaged very badly. So that means that there is something. So we need to assess that whether the condition of that particular building is okay as per our codal requirement, as per our say earthquake requirement needs. So, and you see what happens that even during the routine service of the building also it gets deteriorated. There is a deterioration, natural deterioration is definitely occurs. At that time you will find that there sometimes you will find that there is a corrosion, sometimes there are design faults, sometimes there are say construction faults are there. And so we are to see that okay, during the routine say it's service period also, the building is well maintained and any type of defects which are there, so they are properly assessed, and after assessing them the proper remedial measure is taken, is necessary. So there is it's an important thing which is going on. This thing is the in situ monitoring of the structures also, health monitoring of the structures. Even health monitoring, okay, you have a sort of I compare always that a building or any structure to a human being also. So you have a different sort of a systems. You basically there is a need that you carry out your regular medical checkup. So from that point of view also, if you go, you get your blood test and you get your this ECG done, you get your heart test done, you get your liver test. So all those, so these are different things basically which human body does. So similar way we should see that okay, buildings regularly we are carrying out their monitoring, and then we are based on that monitoring we are assessing how much it is basically prone to the damage during any disaster occurring. So there are many other ways also. I think if you see that in case of monitoring of structures, you see you install some sort of sensors, like routine sensors are installed at a critical junctions, and then those sensors you can find out through those sensors again they will be regularly giving you data, like you have a in your this thing you have air monitoring systems also, air monitoring stations. So where what you are getting is you are regularly getting the what is the carbon monoxide data, what is NOx, what is your SPM, what is your PM 2.5 PM. So that way also from the building also you should be able to find out okay whether how much is the whether cracks are there, or if cracks are occurring, whether they are still active. So those sort of a regular, so you can have a systems which can be installed inside the building, and then you can get the data on your say monitor on your computer and find out that what is happening and what is what need to be taken. So for a very say important structures, like we have a very long nowadays multi-story buildings or say bridges, where I think regular monitoring is required, where a question of life and death is always associated with these sort of important structures. So there also I think we should need to have installed this sort of a sensors inside the building. From there we can get the data, and that data can be interpreted and monitored. So so this is the one thing, and then another thing is that we have to that is what Duggal Sahab was explaining, that we need to have a regular condition assessment of the buildings, and nowadays government has made mandatory also that whenever there is any important building structure, so after I say every 10 years you need to get a it's a stability certificate of that particular building. So depending upon the various tests carried out at the site. So those tests are basically we can say that there are many tools are available. I will say that visual inspection, if you go there, also see that see the pattern of cracks, see whether crack is still active, or any say plaster has come, or any say concrete is coming on, whether visually you are finding it is the structure is corroded or not. So from there you can find out that yes, visual inspection will give you the first sort of information about the building. Like it is just like you go to doctor, I have a temperature, and temperature is a symptom. Basically that okay, temperature may be due to you are having typhoid, you are having some flu, you are having some viral infection. So from there you will have to assess what is the cause behind that particular this thing, so that we can carry out the proper remedial measure. So any say and nowadays once we are carrying out the condition assessment of the building, so depending upon the earthquake zone, we have to see that what sort of remedial measures are required in that for that particular building. So it has to be retrofitted. That is what we say, retrofitting of the building. So retrofitting of any structure is based upon your condition assessment. And in condition assessment, one of the say methods is through the using the non-destructive test methods. And generally you see that when this concrete buildings having concrete, so they were constructed, so at that time it was thought that it is a maintenance free material, its life is indefinite, it will not deteriorate. But with the passage of time we found that yes, concrete is not a sort of a completely maintenance free structure, it requires maintenance frequently, and that is to be done through various methods. And so I say that this visual inspection, if you say this one, there's a visual inspection is also part of your regular monitoring, and then we have to carry out the testing at the site. The important thing about this road safety testing technique is that we are not causing any damage to the building. So we have basically some sort of equipment or tools available to us, by which we can assess the quality of the present condition of the structure, quality of construction, or some whatever we want to, or causes of the deterioration in a structure, that can be assessed using without causing further damage to the structure. Those conditions are known as the non-destructive testing method. So at a time of a condition assessment, the important thing is is to find out whether how the structure is performing. So a structure, when it fails to perform, the function for each one design is basically that we say it is under distress. That is that stress is basically due to many reasons. It may be due to the errors in design, detailing and construction, use of substandard material during the construction. If many times what we do is we overload the building, put extra load on the building, then there is a lack of construction quality during construction thing. Sometimes we have this earthquakes, movement of soil, or change of temperature. Then there are many external influences, earthquake, wind, fire, etc., which again leads to your sometimes corrosion is there. So basically these are the things basically which are looking during any condition assessment of a structure. And going into say causes, faulty design means okay, you have a let us say what are the factors which are influencing the concrete structure, causing distress. What is the faulty design? Their quality of the materials, poor construction practices, abuse of the structure, environmental effects, chemical effects, and internal stresses, mechanical causes, etc. And you see that after hardening, once the concrete is in a hardened stage, so you will find that okay, there are physical, chemical, thermal, and structural things which are affecting which are causing basically routine deterioration in a structure. And this particular slide shows that one of the factors which is responsible for deterioration is the permeability of your concrete. Because if there are more pores or more permeability or more moisture ingress into any your concrete, so it will lead to further more reactions into your concrete, and those reactions will ultimately lead to corrosion. And then which causes the breaking of your bond between your steel and concrete, ultimately leads to failure. And always you can say corrosion, you can always relate like a cancer to a human being. So corrosion in a building is just like a cancer, very difficult to take care. So different so once we are causing damage assessment, so with the assessment methods available to us, as I said, is one is a visual observations, documentations available. You have always some drawings and some say site notes or some other observations which are recorded. So from those records we need to see. Then measurement of a geometrical parameters. Yes, you have to check your original design, and depending upon your design, you have to find out whether that size of the columns or size of the footing or size of the beams or size of the slab is proper or not as per your design requirement. We tested one particular building that was a building located in the army area in Leh, and there when it was tested for this condition assessment and this thing, that it was found that it was the columns, they were not having the proper size as is required for because it was a type zone 5 located in a zone 5, and the thickness of the slab and the thickness of the columns were on the lower side. And so means that okay, you carry out your physical and geometrical measurements also, and then we have to basically carry out certain experiments to evaluate the material properties and its member behavior, which include your that will include your non-destructive testing, your partial destructive testing, and load tests. And depending upon what are the results, where you have to carry out the interpretation and analysis of the test results, formulation of the repair materials, and post repair evaluation will be based upon your this thing. In visual observations, you have to see that what type of cracks are there. From the crack pattern, you will be able to find out it is a shear failure, it is a failure in compression, it is a failure in tension. So from there, so you have to observe what is the width, what is the depth of the crack, what is the length of the crack, and then whether that particular crack is still active or not. Rust staining, many times when you go to any structure, you will find that it is there is a particular cracks along the reinforcement, or there is a small rust spots on the appearing in this thing. So you have to identify those buildings. Then spalling, as I said, the bond between concrete and your reinforcement generally fails when it is when corrosion starts. So you have to find out whether at which location the spalling is occurring. Dampness, you have to check with dampness also. in the building, and that dampness basically most of the problems in the building will start from the dampness only. When the dampness start entering into your different building components, so at that time the most problems will start. So dampness is a very, very important this thing. I will say that 80% of your failures are due to dampness, proper drainage, and condition of the foundation also. So documentation means, okay, you have to both drawings and photographs available. You have you see the types of pattern of cracks. Again, I have listed some spalling. You see that abnormal distress, discoloration, then deformation, any observed, history of construction, when it was constructed, what was the original quality of construction, analysis and design methods with assumptions made, and type of the material used during construction. Geometrical parameters, you see that what are the column, beam, slab dimensions, vertical alignment. Many times we find that the alignment of the column is not straight, and generally there is some sort of a offset when we go from one story to another story. It is a very common this thing. Then any deflections or deformations in any it's a part of a component of the building. So these are the factors to be recorded, but these are all, you can say, visual things. But when we go to the site, you see your records, what is the present condition, what is the present thing. That is very important to assess, and for that we are using the non-destructive testing thing, which we in a short form we call it is a NDT. So basically that when there is any sort of doubt regarding strength of a strength of the concrete or strength of the concrete member, at that time, just so we so any in case of any doubtful thing, so we have to see that we have to find out what is the present say strength of the concrete member. So all these factors like due to any say, deterioration occurring due to overloading, fatigue, chemical action, fire, explosion, weathering, etc., can be ascertained through using these NDT systems only. Generally, you can see methods which are in situ strength methods which are used for concrete quality are the say designed loading system. You load that particular building to the design load for which it has been designed, and then see what is the deflection occurring that you made it actually. Actual loading system, provide that, and then you can see what is the new use according to that, how much loading is this to be this thing. So you can see that generally in a concrete, cube strength is the only criteria on which we determine the quality of the concrete. But sometimes cube, there are certain reasons. I am not going into this, but it is not a topic of your thing. So, but there are certain things from which we are not interested in cube quality. Many times cube fails or some say deformation occurs in a building. At that time we have to go for some other methods, and those methods will include your non-sorting testing methods also. So coming straight to your this thing, that what are the type of most commonly used NDT methods are basically when we use these non-software testing methods, so we club them into different categories, like depending upon that which property of the concrete we are measuring. That property may be the hardness of the concrete. If it is a hardness, so that means that hardness has been correlated with the strength development or its present issue strength. Then what we use is to find that, okay, we send certain type of waves into your structure. So those waves we note down that, okay, what is the travel time, and they were taken from to travel from one point to another point, and depending upon your compactness and your density or your absence of cracks or wires, that your waves will take their own time to reach from one point to other point. So we note down the time and find out the velocity, and that velocity has been again correlated with your quality of the structure and the strength of the concrete also. Then to measure your this corrosion into your structure, so we have the methods which are based on your mechanism concept, and there these methods are basically through by generating a magnetic field. We can measure the say to what extent the corrosion has taken place, or what type of reinforcement provided, what is the dia size and other things are provided. Those things are there. Then you have the so these are the things basically what we say. These are the most of the things are this thing. So that is what I said. The objective of the non-safety testing is again to have a proper, to know the present quality, to evaluate the structure with respect to their damage, sort of to what extent they are prone to damage. Then estimating the compressive strength, identifying the cause of damage and source of problem, determination of the material property, determination of extent of damage, then assessment of safety and serviceability of the structure, then formulating remedial measures and preventive measures, determining the position, quality, quantity and condition of the reinforcement, estimating the cost of repair or replacement, increase the confidence level of the few destructive techniques also, because in a says building, you cannot basically have sort of this thing, the load test at each and every location, or you cannot have basically take the core from each and every location, means you cannot damage the structure. So basically you a particular identify a particular area where you can actually see that okay, what is the present condition by performing the load test, and through whole of the structures these tests will help you. Non-safety test can help you to evaluate the complete structure. Okay. So if we say purely non-safety test, the commonly used test, we say that rebound hammer test, ultrasonic pulse velocity test, half cell potential test, concrete resistivity meter, permeability test, penetration test, pull-up test, cover meter test, and partially resistive test will include the cover test, and then you have the load test basically. And you have some other instruments which can be used for this. Is the for determining the different properties of materials is the impact echo test, then surface penetrating radar, thermography, image scanning, and endoscopy. Like I said that okay, as a human, we are a human being is beings. Various tests are carried out on the human body also. So similarly, we have basically tests available to us to find out the damage assessment or maybe condition assessment, I will say, to a particular. So this is the remote hammer test. No, I will not go into detail of its working and all also, but yes, all these tests basically measure a particular property of that thing, and depending upon that property of your say that has been correlated or calibrated with reference to your either a strength parameter or your whatever the other property we are looking for. So here the round hammer, basically here what we are measuring is we are measuring the hardness of the surface. It is nothing but a very simple instrument in which we hit on the surface of a concrete. It can be used on concrete also, it can be used on masonry structure also, it can be used on nowadays. That hammer can be used for even your wooden and your other structures also, but their basically specification of each and every particular hammer is different. So for concrete hammer, there are generally three types of hammers are available. One is the N-type hammer, other is your N-type hammer, and sorry, P-type hammer. And so these depending upon in which range we are working, we can use the hammer. So this is just showing that this is the concrete surface. Here if you go, this is your concrete surface. If you see, this one is your concrete surface. This is a plunger of hammer, and this spring is important here. You can see this spring, because this spring, this is a round mass basically on which the name has been given to this as a round hammer. So you can see that this spring basically when you hit it against your surface, when you hit it against your surface, so it will basically rebound the hammer, and this mass will come back depending upon the hardness of the surface. And once your surface hardness is there, Like you see, this is the weight. So this rebound hammer will basically move depending upon the hardness of the surface and the elasticity of this particular spring, and how much rebound it does. This mass basically gets due to your impact. So that is measured in terms of a rebound number, and that rebound number is indirectly related to your strength of the structure. It's a very simple instrument, gives you a very direct reading of the strength, and very easy to operate. Within say 1 hour you can scan basically a lot of quite a good area of your building. Okay, so these are I think say measure the hardness of the surface. Rebound number is generated. Large rebound number, larger is the rebound number, harder is the surface, and a qualitative test and strength correlation is based upon your correlation graphs. These are steps to be followed. I am not going into detail of each and every step, but definitely what we do is we select a particular 1 feet by 1 feet area at in concrete. If we say one column is there, we select about 5 locations or 5 to 6 locations, or in each location we will hit about that rebound hammer. Basically plunger is hit against about 10 locations, 10 locations in 1 feet by 1 feet area, and we take average of 6 readings. That reading say average comes about 30, 32, 34, 33. Average of those reading is taken at 5 locations for each location, and then we say that there are 5. What is the average? Against that average, we read the strength. So basically, the important thing with using the hammer is we will be able to identify the areas which are having low strength. Because
Hello, sir.
Yeah. हाँ बोलिए.
Hello.
Yeah.
Hello, sir.
Yes, you are audible. Please carry on.
How to determine the dampness of the building?
Pardon?
How to determine the dampness of the building?
How to determine
Dampness of the building, sir.
dampness of the building? Okay.
Yes, sir.
Dampness, yes, you have a basically moisture meters available to us. Maybe I think in a if time permits, not today, but sometime we can show you. We have got a moisture meter. So moisture meter is nothing but it is having a sort of a pointed pins, and that you pin basically put it on the surface, and that surface will tell you what is the dampness of the surface of that particular thing. So basically that methods are available to us. We have the ready to use moisture meters available to us. You can determine the dampness using that particular this thing. Or then there are things like laboratory methods. You take a sample and weigh it, and then saturate it, and then basically dry it, and then you find out okay how much moisture is there. That measure can be applied. But yes, in situ method is be used by using moisture meter very commonly, and very common thing is there. I think that answers your query.
Okay.
Yeah, I think I will request the Duggal Sahab to put the instruments here, and then you can those instruments can be shown to you, right? Okay. Anybody else? So this is the if you see this particular table here, you will find that the instrument we have the rebound numbers available to us. Like you have this greater than 40. Quality of the concrete we term is very good. We can basically with the help of a graph against this 40 loading we can find out what is the strength, in situ strength also. As I said, I was giving the example. We were having a sort of a pier being constructed, and when that testing of that pier was done, it was found out that the cement of one particular lot of a cement that was giving the low strength, and it was a cement. It was a pier having about 20-meter height and 7 by 7 meter basically your width and this thing. So 7 meter plus 10-meter height. So it was not known where that poor quality of the cement has been used. This thing. So the best available method was to use the rebound hammer. So rebound hammer test was using, and particular in that particular stretch where that cement was used, which was having the low strength, that was identified and it was rehabilitated. So it was a very quick and easy method, by which we were able to identify okay weak point in a particular casting of that particular concrete. So you can see that, and it is very suitable method when we use this method, and very commonly used and a very effective one also. Depending upon the Raymond number obtained, you get this reading whether the quality of the concrete is very good, hard layer, good layer, fair, or poor quality. Or the you get a lesser than 10 value means the quality is very poor. So, and very easy method. This is the graph. I can say on this side you will find that this is your see on this is a Raymond number which we are writing. So if it is a 40, depending upon on which angle, like it is a horizontal, it is a upward, it is a downward, we read the scale. Again this 40, if it is a 0 degree, that means we are getting a strength of about 340. So just read from the graph. If you want to get very accurate old structures, it is not because then you have to calibrate. So to take the few course, calibrate in the lab, and then you can make your own graph, and you can assess the basically present condition. These are the particular type of graphs, and various factors which influence your value is again type of cement, the type of, I'm not going over. This is the N-type hammer I was saying. This is, it is being used at the site. This is another type of hammer, this is which we call is a non-recording, that is again N-type, but you need not take the reading. Graph basically it records all the readings. So this is again being used. This is another type, P-type hammer, which is again used for concretes for having low strength, lesser than 10, maybe from 5 onwards. It can be used for determining the strength of the masonry also. So this is a P-type hammer. It works on the same principle. This is a M-type hammer, basically where the mass concreting, like in dams and in airports. You can see this is again being used. These are the, again I have basically just pointed to this, a P-type. This is again a microprocessor based. This is again a digital hammer, and this is the non-recording type. This is that having that Raymond number scale on this particular this thing. This is the anvil basically against which we test the its calibration. So that calibration is again to be checked. Regarding accuracy, I can tell you, when 2 days back we were testing a site, a bridge we were testing, and their engineers, they came, basically they tested cubes for 7 days cube actually, and those 7 days strength failed basically. So they were having the test for 28 days and all that. Again on the 22nd day we were carrying out their test using the Raymond hammer also, and we found that the Raymond hammer value was giving the strength up to, it was a high grade concrete, high strength concrete up to M60, and then we were testing and we told them, okay, this is the value, which is the strength is coming like that only. And there was another person who tested, private person who tested that particular concrete using his own instrument, which was not properly calibrated, and he gave a result. It is a poor quality concrete, not the strength has not developed to that extent. So basically then we said our instrument is okay, because we are carrying out regular checking, regular calibration, and when those cubes 8 days tubes were tested on 24th, and that strength obtained was exactly 62 newtons this thing. So, and we got at the site using Raymond hammer was 60. So that is the accuracy basically, but if you do it properly only then, but if you don't do it properly, your accuracy is not that good. So methods, advantages: simple, speedy, inexpensive. Limitations are it gives compressive strength up to a limited depth from the surface, and accuracy is plus minus 15% to plus minus 25%. But if you compare it with your results of the cubes also, when the cubes also, code says that plus minus 15% is acceptable. So it falls within that range. Then another method which is commonly used for carrying out the damage assessment is the ultrasonic pulse velocity method. It is again another method which is based on the on the principle of propagation of certain type of waves into your structures. So you see that this is a ultrasonic pulse velocity instrument. These are the two probes which we call is a basically one is the which we call the transducer or probes also. One is the transmitter, other is the receiver. So transmitter will send the wave and receiver will receive the waves. and waves, they travel from one, and the quality of these wave is that, okay, they are not able to travel to any air gap. If there is any air is there, air pocket is there, so it will not travel to, it will take a longer path basically to travel along that particular this thing. So so what we do is we record the velocity, time taken to travel a particular length, and that velocity we get, that velocity has been correlated with your quality of the concrete. Basically this instrument gives you quality of the concrete rather than directly strength, if you go by codal provision. But if you are calibrating your instrument, you are this particular thing against your this thing, you can check the strength also using this. We tested a railway bridge. It was a precast bridge, and newly constructed bridge, which was having a which was basically, I think all you understand, maybe you may be a different background also, but there is a one particular problem in concrete is which is called the honeycombing. Honeycombing means that, okay, the your aggregates aggregate, because you see the concrete is made of your cement, sand, and aggregates. Aggregates of different size. So those aggregates and sand there, it is not properly mixed. So then you will get, but what we'll do is you will find a lot of open wide spaces into your concrete. So this particular instrument is good. So that bridge was having that honeycombing also, very railway bridge, and very honeycombing to an extent that, okay, the concrete lumps can be taken out by the hand also. It was not compacted to that extent, and it is to be rehabilitated. So we use this instrument to rehabilitate that particular bridge. First we assessed how much damage has occurred to that bridge, and depending upon that, this thing we just tested that we were able to carry out and rehabilitate that particular structure, I think at a cost of about 4 to 5 lakhs, whereas its demolition plus reconstruction cost was in crores. So against crores only we were able to do it within a very, that is the basically thing that, okay, even for any type of a structure they can be used. This is the instrument being used at the site, ultrasonic pulse velocity test. So it checks the homogeneity of concrete, your presence of voids, cracks, and general loss of integrity, qualitative and relative condition of the concrete, and combination of rebound hammer and UPV values helps to identify the prone locations also. This is the I think this is the probes. One probe is on one side, other probe is on the other side. Waves travel directly. Waves travel in all directions basically. Waves are going in this direction and this direction also. So basically we are receiving, we are taking that minimum time. So you see that straightness is important. If it is a travel, we pick up a only in this direction diagonally, so it will take a longer time. So we have to see that, okay, what is the minimum time taken by particular wave. So we can surface readings can also be taken. See, this is again same direct, semi-direct, and indirect method. This is the basically that code which gives the thing, okay, how to interpret your results. This is just a behavior of the concrete in different things. So that is what the important thing is. If it is a crack, so what is happening is the wave, it is going, the wave which is straight wave is not picked up. The wave which is taking the longer path, that is picked up. So basically it gives you a low. So if you are having a through and through crack, that means you are not receiving wave at all from other end, because waves are not able to travel through a wide space. So you can identify the type of cracks. Even with the help of this instrument, we can also find out what is the depth of the crack also. This can be found out. So we are carrying out this, I think already I have explained. This the table gives depending upon your concrete velocity, what is the quality of the concrete. So again it explained in detail how to carry out your this thing. This is the one particular thing by which you can identify basically what is the depth of that particular, like concrete roads are there, so you have to find out in the concrete roads what is the depth of that particular thing. So you can use this ultrasonic pulse velocity to find the depth of the concrete. So we are taking the readings at different this thing, we are taking this thing, and from there we will able to, because the velocity, once your waves, this wave is going like this wave is flowing like this. So when we take a ratio, so one wave will came here and it will picked up by, it will go from this place and will be picked up by this. So other wave will be lost then. So from there we will be able to find out the depth also. If it is a crack also, we can find out the crack in a particular thing. Okay. This is what crack depth can be found out. So corrosion, it is basically whether corrosion will occur or not. So this can be also found out. You can see that high value, high remote number, it is means that it is not a corrosion prone. Medium range, surface delamination, and corrosion may have just started. Low UPV value, high rebound number. So it is again what happens that in a concrete where it is a corrosion is there. So it will give you a high rebound number but low values of UPV. So from there you can assess that okay, what is the condition. Then low UPV value again. So these are the factors basically which affect your concrete structure and velocity and all that also. This is the core, concrete core, which is testing. Again, it is testing is prescribed in your IS 516, 199 and 456, and you take the cores. These type of cores are taken and they are and their surface is prepared and they are tested in the CTM. Yeah, this thing. So you can basically, that is another method to identify the quality of the concrete and all that also. So you can see that okay, it is used for determining the compressive strength. Small cores for chemical tests. Then if sometimes you have to insert the water pipe and plumbing line also, there you have to find out okay from where to take the route, whether your steel is coming in between or not, because you have to cut a core. So you can use this also. This is again core being taken. Core basically can be used to determine the strength. Yes, it is basically used for that purpose only. And then you can go take out the petrographic analysis and chemical analysis also. Like chemicals, if you have to find out colloids, sulfates, because they are also causing the corrosion, so you will be able to find out by taking to chemical testing. You can find out what is then. Okay, what samples and what is to be testing. So we have to just not going into the other thing. So we have to how the core strength is estimated. Then you have the chemical test. Chemical tests are basically extent of carbonation, because carbonation is the one particular phenomena which causes corrosion into the concrete. So if we are able to arrest the carbonation in a concrete, we can basically, so assessing the extent of carbonation in any concrete is very important. So basically if we do that, because if you see the concrete is an alkaline material, its alkalinity is very high, and once it is it started getting say carbonation starts, so what happens that it alkalinity goes down, and one alkalinity goes down, the corrosion process starts. So basically that is related to corrosion. So we have to see that from that point of view, the corrosion. So it is very important to determine how extent of carbonation using the carbonation test. You see, this is the basically carbonation is nothing but a chemical test where you must have used in the laboratory that phenolphthalein indicator, which is used in the titration method. And that titration method basically what is it? When you are and that reagent which you are using is the titrator, is basically that changes from alkaline to this acidic medium, so it color changes. So same principle has been used here also. So if it is a pink, that carbonation indicator is pink in color, once you spray it on the concrete surface, you will find that it color. If it is not carbonated, you will find a pink color. But if it is a carbonated, you will find it is a colorless thing. So that means it is a to location up to which, like in your this thing you are saying, it is from covered from top to this thing here up to this extent it is carbonated, and this color, this means this is not carbonation is not there, because it is having the this color. So from there you can identify. So so you can calculate the pH value. So pH value means that okay, from here you can find out whether it is corrosion prone or not. So okay, depending upon high pH and the low pH and your this, you can find out what is the probability of corrosion in that particular structure. Chloride content, again, it is nothing but a titration method. You take your sample into your this thing in the lab, and from that lab you carry out the titration and determine what is the chlorides present, just like you do in your environment lab. Similar way you can find out the, so you have a, then you have a one RSPT test also available to us where, where we can, that determines the chloride ion ingress into your concrete structure. So this can also use to use that also. Then another important thing is to know the corrosion mapping also. How much is the to what extent the bars have corroded. So that test is known as the half cell potentiometer. It is nothing but what we do is we pass the current through your we make a half cell sort of a cell, and that is through that we pass the current, and through that current, basically, that depending upon your corrosion you get the voltage rating. It is nothing but you have a voltmeter attached to it. So basically you get a voltmeter reading, and that voltmeter reading will tell you to what extent the corrosion has occurred in your system. So that is another good method to assess the damage in any concrete structure. Then many times again it is important to find out in any structure, because you see that your zone requirement has changed. Earlier India was divided into 5 zones. Now it is a 4 zone. There is no zone 1, zone 2 to zone 5, and so depending upon your requirement and all that, your things have changed. Again your reinforcement detailing or requirement has been changed. So it is important to determine, okay, what is the present condition of your reinforcement inside, what is the cover to reinforcement. Cover is important from carbonation point of view also. So there you have to find out. This is the rebar. This is a bar scanner, can be used for this purpose. This is a very good instrument to locate the bars, to measure the concrete cover, to measure the rebar diameter, and measure the rebar spacing. So complete reinforcement details can be determined. We had a certain buildings which were given to us, which were where the drawing was not available. Extra stories were to be placed on them, or they were be constructed on the top of this thing. So we, using this rebound hammer and using this your rebar locator, and we were able to identify the building and redesign the building according to the present conditions requirement. So this is the instrument used at, okay, how this is used. There is a probe. That probe is basically moved on the concrete surface, and your it will record, that probe will record what is the diameter, so without causing this thing. So you can determine diameter, spacing, and what to cover to the reinforcement. Okay. These readings can be recorded, and is again same thing. You can, with the help of a software, this is a soft cell potentiometer basically reading. So you can, with the help of a software, you can find out which area are more corrosion poor, which are area are less corrosion poor, which location those areas can be. Okay. This is a one particular thing in progress. You can see that slab has fallen. You can see this slab, and the concrete has fallen from here, and this is all corroded because the bond between concrete and reinforcement has broken. This just table tells you this is a 95-55%. That means depending upon the reading, if it is negative in this range, it is 95% corroded. If it is in this range to this range, you have 50% corroded. If it is reading is more than this, it is 5% corroded. So from there you can find out this thing. Resistivity is again another method which is used to find out corrosion level, again based on same principle. Here we are measuring resistance in terms of voltage meter, and that's other working, and another thing is almost same. So you can see, depending upon your resistivity meter, you can find out what is the corrosion levels in your particular building. So negligible, low, high, very low. So depending upon readings obtained at the site. So so these are the basically test results. Corrosion probability can be used by using this your resistivity and your this method also. So you carry out the test at the site and find out what is the corrosion level. Very important, because corrosion is just like cancer. So we have seen that, okay, there are different type of tests. As I explained, surface hardness test, dynamic and vibration methods, this ultrasonic pulse velocity, acoustic emission. What I have explained you most commonly used test. So then magnetic methods like ferroscanners and these rebar locators, electric methods like your half sun potential meter, etc. They fall under this category. Electromagnetism methods or radar methods are there. X-rays are there, gamma radiography is there, and permeability methods. Already I have told you this RSPT and other methods. Air, gas, water permeability tests are available to us. Partial destructive test we have already explained. Pull of this core test, etc. They fall into category of this thing. Chemical test. Already I have explained carbonation, chloride, sulfate, etc. They fall into the category of the chemical test. You can have a crack meter to observe the crack monitoring, abrasion resistance. Now you can find out the other properties also. So these are the tests, basically parameters used in the compressive strength. We have the remote hammer, Windsor probe, ultrasonic pulse velocity and core test, Capco and pull-out test, and combined methods also. To determine the fracture strength, we have the break-off test. Direct tensile to pull-off test, basically, yes, break-off test again, concrete quality, homogeneity, honeycombing, you have the ultrasonic pulse velocity plus echo, gamma ray radiography test, then damage, fire, blast, earthquakes, we are using the remote hammer, ultrasonic pulse velocity and acoustic emission test there. Again, cracks and other water tanks, etc. We are having this water pulse velocity, acoustic cracks, etc. Pile integrity test is again one which is again based on the propagation of your velocity waves into your structure. In case of a steel also we have the test like your corrosion for where we are using half cell potentiometer, resistivity method, carbonation, chloride. Condition assessment, again you can see the by putting the camera inside, you generally they test called the endoscope and boroscope. Integrity and performance, again caustic emission, radar test, etc. can be used by using these methods. So these are the, you can say, most commonly. There are some other methods also, like nowadays we have a thermal cameras. If you take a photograph of that particular thermal camera, I may be having, if you have a time, I can still show you those photographs if available to me. Yes, any questions?
Yes, sir.
Yes.
कितने टाइम में टॉपिक रहेगा सर?
Okay, so we can stop here. And any question or anything else, we will continue if required, maybe on some other day. Yes. You have any questions? No? Then we can call off today's this thing. ठीक है? हैं?
Hello.
Hello, yes.
Good afternoon, sir.
Good afternoon.
Hello.
हाँ बोलिए बोलिए यस आपकी आवाज आ रही है
हेलो
हाँ हाँ प्लीज प्लीज गो ऑन
Hello.
हाँ जी बोलिए
Sir,
Yes,
I
please.
have one question.
हाँ हाँ प्लीज हाँ बोलिए
What is
बोलिए
carbonation?
व्हाट इज कार्बोनेशन
What is carbonation, sir?
Carbonation is basically a type of a
What is carbonation?
okay yes let me explain you I have
What is
understood
carbonation, sir?
हाँ कार्बोनेशन जो कंक्रीट में कार्बोनेशन है बेसिकली इट हैपेंस बिकॉज ऑफ इनग्रेस ऑफ कार्बन डाइऑक्साइड एंड वाटर मॉइस्चर into the concrete. What happens, concrete is having a compound which is called as calcium hydroxide. That calcium hydroxide, where it is a reacts with the carbon dioxide from the atmosphere and moisture again from the atmosphere, it forms a carbonic acid. So that gets converted into calcium carbonate. So your cement which is present in the concrete, instead of calcium hydroxide, it is having the calcium carbonate. That calcium carbonate is nothing but carbonation, which we call, because it is it is because of the reaction of carbon dioxide with water, or with, you can say, moisture present into the atmosphere. So that is why it is called the carbonation. Is it clear? लगता है क्वेश्चन पूछ के चले गए हैं.
सर आपकी अब बोलो थैंक यू.
Okay, sir. Thank you.
ओके, ठीक है, राइट.
सर जी ये बीच पे लगा दे स्क्रीन गिलाउड से.
एक दीपक का हमारा था है, इसमें जब लास्ट टाइम
Thank you. दादा अगर बात ही ना हो.
फरवरी में हमने एक प्रोग्राम किया था, उसके इसका फोल्डर पड़ा हुआ है यहाँ पे. अच्छा, किसके पास है वो सिस्टम, पता नहीं. एक एनवायरनमेंट का था मेरे ख्याल, हमारा किसका था, 12 से. अच्छा, उसमें कुछ हमारी प्रेजेंटेशन थी.